Hello students, I hope that you are good, well and fine. Today we will be seeing the solution of NCERT exercise 5.4. We have discussed enough theory to discuss this exercise. Okay, so let's jump to our first question without any further ado. So this. So we have to do what? We have to find the derivative of it, dy over dx. One way is that we can clearly use what method? We can clearly use the quotient method. If you remember the quotient method, u by v whole derivative is equals to, in denominator, v square, u derivative v minus v derivative u, this way. Or the another way is that you can use your log function also. So how you are going to use your log? Very simple. Okay, so let me uh, go it by using what? Using this. Okay, so this will be what? Sine square x. Here you will have ex derivative, which is same. Okay, multiply with sine x. Now minus this will be sine x. Sorry, now ex will be same. Derivative of sine x will be cos x. Okay, and this will be e power x in brackets sine x minus cos x divided by sine square x. You will get your answer. Okay, we just use this thing. Okay, I hope that it is easy to understood. Very simple, very easy. We just use this form. Okay, let us move to next slide. Problem number 2. So problem 2 says the same thing. We have to find the derivative of this and then multiply the derivative for this. Okay, simple. So derivative of sine inverse is 1 by root 1 minus x square. Okay, now derivative of e is e power x is e power x. This means e sin x. So you will have your answer as 0. Obviously we are taking x belongs to open interval minus 1 to 1. Yes, as denominator cannot be 0, that's why I am taking open interval minus 1 to 1, and inside root we cannot take negative values. Okay, so you will get this as your answer. I hope that it is quite simple. We use what? Chain rule, and we use a little about what the functions, that how do we define our function to be legit. Okay, now let us move to the next slide. The next slide says third slide, or the third question, e power x power x. So first of all, what we will do, we will derivate this. What you will get after derivating this, you will get 3x square. Now multiply with ex. So e, the derivative of e is just e. Now put the thing. So you will get your answer as this. 3x square multiply with e power x power 3. Okay, I hope that it is very simple to understand how we are getting these. We are just using our concept of chain rule. We are using our concept of some standard derivatives such as x power n derivative is equals to n multiply with x power n minus 1. Okay, and ex derivative is just ex. Okay, we are using these direct forms. That's it. Now let us move to next question number 4. Question 4. So question 4 says find the derivative of this. Oh, very simple. First of all, this is the outermost function, this is the second outermost, this is the third, and this is fourth. So first of all, find the derivative of this. So okay, so give numbers 1 2 3 4. Find the derivative for 1, it will be minus 1. Now multiply with derivative of 2, it will be what? e of minus x. Now multiply with derivative of tan inverse. Tan inverse is 1 divided by 1 plus whatever inside. So you will get e minus x whole square. Now multiply with sine. Sine is cos and whatever inside, tan inverse e minus x. So you will get your answer as this. Okay, so this will be e minus x minus 1. Sorry, it's in a product. So minus e power minus x multiply with cos tan inverse e minus x divided by 1 plus e minus 2x. That's it. You will get your answer as this. Okay, I hope that it is very easy to understood. What is happening in such type of questions, you give your expression numbers like these, innermost function, then outer and the outermost function. So after giving your number, then find the derivatives of the given specific terms, specific forms, okay, and then multiply them, as you can see we did here. Okay, so this is very easy way to solve such type of questions. You can solve them by just in 2 steps or 3 steps. Okay, if you apply the correct form, if you apply the correct thing, you will get the correct answer in just 2 to 3 lines. Okay, now fifth problem says about what? Let me see. So log of cos e power x. So give numbers. So if you try to give this as 1, this is 2, this 3, this 4. So for 1 it will be 1, for ex it will ex, for cos it will be minus sine and whatever inside ex, for log it will be 1 upon whatever inside cos of ex. Okay, so this means you will get ex, the minus sign, tan ex. You will get this as your answer, or you can leave your answer in this form also. Okay, simple. Okay, and obviously what we want, and we know that tan is not defined at minus pi, odd multiples of pi by 2. Yes, so this means we must have this restriction where ex is not equals to odd multiples of pi by 2, where n we are taking as natural numbers. Okay, simple. I hope that it is clear. So as you can see, after giving numbers to the question, okay, or to the expression in the question, you can answer it by just in 2 to 3 steps, as you can see. So far we have covered 5 problems. In those 5 problems we are dealing the same. Okay, so what does this mean? This means if you give your expression numbers, or then it will be easy to apply your chain theorem, chain rule. Okay, what we are doing is applying just chain rule. That's it. We are just applying chain rule, nothing more, nothing less. Okay, so we are applying chain rule, but in a different way, in a different manner. Okay, I hope that it is clear. So please keep this point in mind whenever you get your answer like this. Please write all the restriction, whatever is needed, whatever is necessary. Okay, without those restrictions, the answer will be not completed. Okay, clear? Okay, let us move to the 6th problem, problem number 6. Problem 6 says that ex plus e power x power square plus e power x power cube. This. Okay, so this means we have 2, so I think it will be 5. Okay, it will be 5, not 3, as the next term will be the third term. Yes, it is going till 5. Okay, clear? If this is your expression, then how you are going to find the derivative? Very simple. Find the derivative of this, find the derivative of this whole thing, find the derivative of the terms here, find the derivative of this, and then add them. That's it. You have to do this simple task. So derivative for this will be just ex. Derivative for this will be what? Give numbers, then you will get 2x multiply with e power x power 2. Then 3x square e power x power q. Then 4x cube e power x power 4. And then 5x 4 e power x power 5. You will get your answer. So this will be your answer. Okay, what we used? We used derivative of ex, which is just ex. We use chain rule. How we use chain rule? As we know, if you try to see over here in this specific term, so we took this as 1 and this as 2. So derivate this first number thing, which is x square, you will get 2x, and derivate this ex, you know that derivating e will give you ex. So whatever the thing already there, please put that thing, you will get your answer. Okay, so very simple. If you face any exponent power something, please do try to give numbers, and then after giving numbers in a specific order, please do follow that order and find the differentiation of the respective terms, and then what you have to do is just multiply all and you will get your answer for that. Okay, I hope that it is very easy to find. As you are seeing, we are doing just nothing, but don't worry. This is your first time with the differentiations. So first of all, make yourself comfortable with differentiation process. How we are doing. Watch, learn different types of methods, ways, theorems to reduce your effort, to reduce your errors. Okay. Now let us move to the seventh problem. Seventh problem says, so first of all, think that is there any extra condition over here? As you can see, no. Why? In exponential function, the domain is R positive. Sorry, yes, the domain is whole R. Okay, the domain is whole R. So there must be no exception here, no extra restriction here. Okay, clear? Okay, let us move to the next slide or the next problem. So here one restriction is already given. Why? Because x is inside root. Okay, and root must be non-negative. It can be 0. Okay, so here we have already restricted to what? To the subset of non-zero, which is positive real numbers. Okay, so domain is this, if you try to see it. Now derivative of this, very simple. How you are going to find the derivative of this? Finding the derivative of this, give numbers. So this will be, the root thing will be your 1, this will be your 2, and the outermost, which is the root thing, this will be your 3. Now the innermost thing, root x derivative will be 1 by 2 root x multiply with e root x multiply with 1 by 2 root whatever the inside, you will get this. So now what you get is 1 by 2 1 by 2 root x e root x, and then in numerator if you try to see is e power root x. You will have this as your answer, where x must be positive. Okay, clear? Okay, so how we get it here? It's very simple. We just give numbers. So this will be my first, this will be my second, and obviously this root thing also be there. So that's why it will be my third. So for the first, you all know root x derivative is 1 by 2 root x multiply with this second number, which is e derivative is e whatever the inside thing, which is root x, and multiply with the root. So as we just saw, root derivative is 1 by 2 root whatever the inside thing, as you can see e power root x. Now we simplified it and you will get your answer, and in here you must have this condition. Okay, you must have this condition. If x is 0, then denominator will be 0. That's why you didn't take 0 here. That's why you are taking x is strictly greater than 0. Okay, clear? Simple. Okay, let us move to the problem number 8. Problem 8 says, again we are doing what in 5.4 exercise, we are just doing try to find out the derivative or the differentiation. Now this thing, as you all know, the log base must be what? Greater than 1, as we just saw in the theory session. Okay, we define our exponents and log for base greater than 1. Okay, yes, we can define for base in between 0 to 1 also. Okay, but we just in previous session, in theory session, we just saw for the greater than 1. Okay, now the log domain is the range of exponential function, and range of log is the domain of exponential function. What this means? This means domain for log is positive numbers, and range is any real number. Okay, clear? Okay, now here you will see why we didn't take the x greater than 0. You will see, first of all, give number, so it will be 1, this will be 2. Now for 1 we know 1 by x, multiply with, for log it will be 1 by whatever the inside thing, which is log x. Now this will be 1 by x log x, and if you try to see, if x 0, this will be 0, so x cannot be 0. If x is 1, then log 1 will be 0. You all know that log 1 will be 0. Yes, so this means that's why we didn't take this value. Okay, that's why we are supposing, or this is independently the choice of the writer. Okay, so x is greater than 1. Okay, clear? So very simple. If you give your expression numbers in some specific order, please do find the respective derivatives in that same order and then multiply them. You will get the answer in just few steps. Okay, simple, clear? Okay, and also please mention this such type of condition if there are. Okay, so this is it for the problem number 8. Now we will move to problem number 9. So problem 9 says, let me just see problem 9. Very simple. Problem 9, if you try to use that quotient rule, you can do it very easily. So how? Let me show you. So first of all, in quotient rule, we know the denominator gets extra square and gets multiplied with the differentiation of this function, which will be minus sine x and then minus sine, and then numerator will be same and multiply with the denominator differentiation, which will be 1 by x. If you simplify it, what you will get, it will be, let me just write it like this. So it will be cos x plus sine x log x and x divided by log x whole square multiply with x. Yes, as you can see. Okay, so this x taking LCM, this will be multiplied with this and also with the denominator. So you will get this as answer, and here the restriction will be x greater than 0. So as you can see, x sin x log x plus cos x, the whole multiply with minus divided by x log x whole square. So your differentiation for this given ninth problem will be minus in bracket cos x plus x sin x log x divided by x log x whole square. Okay, simple, very easy. Okay, so what is happening, I hope that it is clear. So we just use what? We use v by u, sorry, u by v whole derivative is same as v square and then u derivative multiply with v minus v derivative multiply with u. We are using just this simple form, the quotient rule. Okay, clear? Okay, let us move to the last problem of this exercise. Problem number 10 of NCERT exercise 5.4. Okay, then we will wrap up our session. Okay, so 10th problem says that cos of log x plus ex. Okay, then we have to find the derivative. Very simple. So if two expression are getting sum, then what you have to do, you have to find the derivative of this and then add. That's it. That's the only thing you have to do. Okay, then what? So okay, so this will be the first step. Okay, clear? Now what you have to do, now give the outermost. If you are facing such sort of thing, then give your number first, the outermost function, which is this. So this will be 1, so this will be minus of sine. Now the inside thing will be the same. Okay, now differentiate them. Okay, now multiply, differentiate them. Differentiating them, what you will get, this will be 1 by x plus ex, 1 by x plus ex. Okay, so if you simplify, what you will get is what you will get. Okay, so you will get like, let me just show you. So it will be minus 1 by x sine log x plus ex. Okay, this will be like this. Okay, simple, very easy. Okay, now what is happening is quite simple, that this can be rewritten. Okay, here we have to multiply it once more, so it will be minus sine log. Okay, minus sine log, this will be what? Minus sine log x plus ex multiply with ex. That's it. Okay, simple. Okay, so what just happened is what? Let me just show you. Okay, so this will be what? Your answer. Okay, this will be what? Your answer. So let me just once again give you how we use our chain rule. So we use, first we find the derivative of this. As you know, the finding the derivative, it will be minus and inside thing remains the unchanged. Now finding the derivative of inside thing, it will be 1 by x plus ex. That's it, 1 by x plus ex. Okay, simple. Okay, so I hope that it is now very easy that how we got our answer. Okay, how we got our answer. So once again, let me just go through it. Okay, so what we just did is find the derivative of this. So it will be minus, so minus of sign, minus sign whatever the inside, as you can see, whatever the inside. Now multiply with the derivative of this. The derivative of this will be 1 by x plus ex. Okay, so if you try to just leave your answer here, this will be also good. If you try to simplify it, it will be also good. Okay, so far so good. We have arrived our answer. Okay, so I think we have to stop it here. So we have discussed every question in this exercise 5.1. So that's it for now. I hope that you understood every problem, every explanation, every step we did. Okay, so that's it. We will be back with more concept, with more questions, with more theory from this chapter, continuity and differentiability. Okay, so again, thank you.